All right. Sorry for the break in transmission. Are we here now? All right. Are we here now? Let's continue from where we stopped. Can you hear me? Can you all 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 hear me? Can we continue now? Alright, so network was bad. My network went totally off. So I needed to start the live stream again. So let's go straight to calculations. Alright, so don't forget to share the link to others so they can join as well. Let me go back to solving this question again, okay? I think the network went off at the point when I was solving. They said the position of the particle is given by x equals to t raised power 3 minus 3t squared plus 5, okay? Where it is meter, we calculate the position of the particle when t is that. So this is like a function. We can write this as x as a function of t equals to t raised power 3 minus 3t squared plus 5. Alright, so they said when t is 4 seconds. So when t is 4 seconds, we're going to have x into bracket 4 equals to 4 raised power 3 minus 3 into bracket 4 raised power 2 plus what? Plus 5. Alright, so x will be equals to 4 raised power 3 should give us 64 plus 3 into bracket 16 plus 5. That will give me 64 plus 3 times 16. 3 times 16 should be 48. So 48 plus 5. So x here will be equals to, is that a minus sign? It is a minus sign, so the minus, this will also be minus. Okay, so we have 64 minus 48 plus 5. So my answer here should be 21. So 21 meter. So obviously, looking at the options, D is the answer. That's the only one that has 21 meters. Are we getting that? But let's just solve. Let's find the average velocity in time interval. This average velocity. Don't forget. Let me change the color of my pen. Don't forget the average velocity. That's V alpha is equals to change in x over change in t. That will give me xf. That will give me xf minus xi over tf minus ti. Okay, so we're given a time interval. We're given 4 seconds and 1 second. So obviously my final time, let's have an initial time. My initial time is what? Is 4 seconds. Is it 4 seconds? Except from what to, okay, from 1 to that. So that means that my from 1 to 6. Okay, from 1 to 6. Okay. So 1 second is my initial time and 6 seconds is my what? My final time. So we have to find xf and xi. We're given that x is equals to t raised power 3 minus 3t raised power 2 plus 5. So we can find xf and xi. Xf is when t is equals to what? 6 seconds. That means xf is at final time. Okay, so let's solve that. So x will be equals to, wherever you see t, put 6. That will give me 6 raised power 3 minus 3 into bracket 6 raised power 2 plus 5. Alright, so x will be equals to that. 6 raised power 3 should give me 216 minus 3 into bracket 36 plus 5. So x will be equals to, when you solve that, 216 minus 108 plus 5, that should give me 113 meter. So this here is xf. So let's solve for our xi similarly. Xi is when ti is equals to 1 second. Are we following? So therefore my x will be equals to, wherever you see t in the equation here, in this equation, we put 1 second. So let's go. That will give me 1 raised power 3 minus 3 into brackets 1 raised power 2 plus 5. So x will be equals to 1 minus everything here should give me 3 plus 5. So 1 minus 3 should be minus 2, and minus 2 plus 5 should be 3. It's 3 meter. So now we've gotten our xf, and this obviously is our xi. We can now calculate the average velocity. So the average velocity will be equals to what? Will be equals to xf minus xi over tf minus ti. That will be, what's my xf? My xf here is 113 meter. And what's my xi? That is 3 meter. All over, what's my tf? That is 6 seconds minus 1 second. So 113 minus 3 should give me 110 meter over 6 minus 5 should give me 5 seconds. So my average velocity is equals to 110 divided by 5. That will give me 22 meter per seconds. That will give me 22 meter per seconds. Is this clear? I hope this is clear, right? So moving on. We have, let's solve the next question. We've wasted enough time. What should we solve? Let me delete this. What should we solve now? The next question, deleting this, we have, let's play with this. We're told that a train changes position function of time from this. Okay, x is equals to what? Is equals to x is equals to 20 plus 5t square. Alright, so find the displacement of the train. We're looking for a displacement, that's change in x. Okay, we're looking for change in x. Don't forget that change in x is equals to xf minus xi. Okay, and we're given time interval to be from what to what? From 1 to 2. That means that initial time is 1 second and final time is 2 seconds. So let's find xf and xi. So xf will be equals to, when xf is when t is 2, right? So whenever you see 2 in this equation, we put, whenever you see t in this equation, we put what? 2. So give me 20 plus 5 into bracket 2 square. That will be 20 plus 5 into bracket 4. That will give me 20 plus 20. So my final position is 40 meter. Similarly, my initial position xi is when t is what now? Is when t is 1. So let's solve for that. So xi will be equals to 20 plus 5 into bracket what? 1 square. That will give me 20 plus 5. That will give me 25 meter. So my displacement, my change in displacement, again, don't forget, is SF minus XI. What's my XF now? We got 40 meter. What's my XI? We got 25 meter. So our answer here, my answer here will be equals to, what's that? Subtract for me. Equals to 15 meter. I hope this is clear. I hope this is clear. Okay, let's move on. B says we should solve for the average velocity between that same interval. Average velocity in that same interval. Don't forget that average velocity is equals to change in x over change in t. That will give me xf minus xi over tf minus ti. Okay, so what is my xf? My xf is what do we just get? Okay, we got 40 meter minus my xi. My xi is 25 meter. We've gotten the answer already to be 15 anyway. Over my tf now. My tf, what is final time? Final time is 2 seconds. Initial time is 1 second. This will give me 15 meter over 1 second. That will be what? 15 meter per second. But the last part says you should find instantaneous velocity when t is 3 seconds. You can see in this case now, we're not giving an interval of time, we're giving just a particular time. Don't forget that instantaneous velocity is equals to dx over dt, which means that we have to differentiate what? X. So what is my x? Our x from our equation is, where is it? Is 20 plus 5t square. So differentiate it now. We're having the x over dt, that's differentiating x with respect to t, is because whenever you differentiate a constant to give you what? 0. Differentiate this 2 here. In case you don't have to differentiate, you can it's very easy. This 2 here multiply the entire expression. So this will give me 10t, okay, raised power 2. Then we remove 1 from 2. This will become 10t raised power 1. So dx dt, don't forget, dx dt is what? Is velocity. So hence velocity as a function of time is equals to what? 10t. Okay, and we're told that when t is 3 seconds, so velocity now will be equals to 10 into bracket 3. That will give me 30 meter per second. I hope this part is clear as well. Any question? Any question? All right. In the absence of questions, let's move to the next question. We don't have time. Let's move to the next question. I'm deleting this question since we've solved it. So let's solve another question. Okay, what should we pick from? Let's pick this. Have we solved this question? Okay, I don't think so. So let's solve this question. The question says, that the displacement of a car as a function of time is this. So displacement S We're using s as displacement now, is 3t raised power 2 minus 2t plus 1. Okay, 3t raised power 2 minus 2t plus 1. So find its velocity at time equals 4 seconds. So looking for the velocity when t is 4 seconds. Looking for the velocity when t is 4 seconds. Okay, so obviously we're looking for instantaneous velocity, which means velocity at a particular point in time. Okay, so how do we find instant velocity? We know that v as a function of time is dx over dt. Okay, in this case it will be ds, we are dealing with s now, over dt. So we have to differentiate this. Let's do that together. So s is equals to 3t squared minus 2t plus 1 plus 1. So when you differentiate, we have ds over dt is equals to, differentiate this 2 multiply everything becomes 60, and remove 1 from 2, that's raised power 1, minus differentiate this to give us 2, this will give us 0. So this ds over dt, don't forget, is equals to v. So therefore v as a function of time is equals to 60 minus 2. Okay, so we're told that when t is what, 4 seconds. So when t is 4 seconds, my v will be equals to, wherever you see t, with 4. That's 6 into bracket 4 minus 2, that is 24, minus what? Minus 2, that will give me 22 meter per second. 22, so v is 22 meter per second. So obviously the answer is B, because B is the only one that has 20 meter per second. So if you want to continue solving, said at what time the velocity of the body becomes 0? At what time? We're looking for time now. We have a formula for velocity now. The formula for velocity now is 60 minus 2. It's over here. 60 minus 2. I said at what time? We're looking for what now? We're looking for time. Will the velocity become 0? That means will v equals 0. So let's substitute. We're going to have 0 is equals to 60 minus 2. Okay, so let's like times 0 mathematics. We're going to have 2 equals to 60, divide both sides by 6. So t will be equals to 2 over 3, 2 over 6. So I'm going to plug my t will equals to 1 over 3, which will give me 0.333 meter per second. So that's meter per seconds now. Sorry for that, 0.333 seconds. Okay, so I think that confirms this answer. Alright, moving on. Next question. The next question. Okay, we're done with this question, so let's delete it. All right. So let's see the next question. What are we solving next? Let's solve this. Have we solved this? No. Let's solve this next. Okay, so let's try this question out. Alright, so we said the position of the particle moving along the x-axis is given as. So again, x is equals to 2t raised power 3 minus 6t plus 5. 6t plus 5. So we're told that where x is blah 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 blah, find the acceleration of the particle when t is that. So looking for the acceleration when t is equals to 2 seconds. So looking for the acceleration, normally acceleration is equals to dv over dt, but unfortunately we're not giving velocity, we're giving what now? We're giving displacement. Don't forget that we also know that the square x over dt square is also acceleration, which means that if I differentiate displacement twice, I will get what? Acceleration. Let's see if that's true. Now again we have that x is equal to 2t raised power 3 minus 6t plus 5. Alright, so if I differentiate, I will having the x dt, which is velocity. Abi, that will give me 6t raised power 2, right? Minus, differentiate this, we have 6. Okay, so this here is the formula for my velocity. Are you following? We are looking for acceleration, right? So I have to differentiate one more time. So I will differentiate. So dv now, dv dt, which is now my what? Acceleration, will give me 12t minus 0. That's 12t. So now we know that acceleration is 12t. Are we getting that? And I told the acceleration, and at the time now is 2 seconds. So when time is 2 seconds, my acceleration will be 12 times 2. That will give me what? 24 meter per second square. 24 meter per second square. So is it? So what will be the option? Option A and B and C looks correct. Let's look at it. They said 24 meter per second changing, or 24 meter per second constant. I said the position of the particle moving, blah 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 blah. As this is given as the position of the particle, velocity is the velocity changing or constant with time. So velocity changing or constant with time. If velocity is changing, it means if it is changing, it means that there is what? There is acceleration, and that also is changing. Okay, so that means that my answer is A. My answer is A. Okay, my answer is A. That's if the velocity is changing. The next question. Next question. Next question. So let's solve this. Let's solve this real quick. So we're told that acceleration A is minus 3 plus 2t square. This is what? This is in meter per second square. So find the velocity at t equals 3 seconds. So we're looking for velocity v. Alright, now how can we get velocity from acceleration? We know that acceleration, okay, is equals to dv over dt. If I cross multiply, I will have dv to be equals to a dt. Integrate both sides, this will cancel out this. So therefore my velocity now will be equals to integral a dt. Understand? That means if I integrate my acceleration, I will get what? Velocity. And that's kind of velocity. Then I have to integrate what? My acceleration. Alright, so v is equals to, following this formula now, is equals to integral what? Integral a, and what is my a? Minus 3 plus 2t square. Alright, and we add our dt. Let's integrate this. So integrating, this is like saying integral minus 3t raised per 0 plus 2t square dt. This will give me, integrating means that we are going to add 1 to the power and divide it by whatever power you have. So let's go. So give me minus 3t, 0 plus 1 will give me 1, and divided by 1 plus the same thing here, so give me 2t, add 1 to the power, that will become 3, then over 3. And also don't forget to add the constant. So therefore my velocity now, my velocity is equals to minus 3t plus 2 over 3t raised per 3 plus c. That's what we told in the question. We're told that to find the velocity at the time of what? of 3 seconds, given that the velocity at t equals 0 is 0. So we're told that when t is 0, the velocity was actually what? 0. So let's impute this into the equation. We're going to have 0 equals to minus 3 in bracket 0 plus 2 over 3 bracket 0 raised to power 3 plus c. So 0 will equals everything will give me 0, everything will give me 0 plus c. So therefore, we say that my c is 0. Alright, so we're now told to find the velocity at t equals 3 seconds. So when t now is 3 seconds, what is now my velocity? What's our equation? This is our equation right over here. We know that v is equals to minus 3t plus 2 over 3 t raised to power 3 plus c. So wherever we see t now, what do we put? We put 3. So let's go minus 3 into bracket 3 plus 2 over 3 into bracket 3 raised to power 3 plus, what's our c? Our c was gotten to be what? To be 0. So v will be equals to minus 9 plus 2 over 3 into bracket 27 plus 0. So v will be equals to minus 9 plus 3 here 1, 3 here 9. 9 times 9 times 2 will give me 18. So add it up, we're going to have 9. So 9 meter per second. So that there is the velocity, I mean, yes, velocity, the velocity of that body. So that there is the velocity of the body. Is that clear? Can I move on? Can I move on? Can I move on? Alright, moving on. Next question. Next question. Let me clear this up. What should we solve next? Okay, let's solve this question. I think this question is actually kind of wrong when I check Adewale physics. So I think they made a mistake here. So I'll try to correct the mistake. They said the acceleration of the body is that. So A is, they said 2, but the value was actually 3. So this is 3. It's a meter per second, and they put t square outside. This is wrongly arranged. I can write this as what? As 3t square, then meter per second square. Not meter per second raised to power 4. This is wrong. That's not the unit for what? For acceleration. So we know that A is equal to 3t raised to power 2. So we are told that if the particle is at rest, that means that if the velocity is 0, then t is also what? 0. Do you understand that? Find the velocity when the particle after 2 seconds. So we're looking for the velocity now, when t now is 2 seconds. This here are the initial velocity and the initial time. This now is the final velocity and the final time. Now for you to get velocity, don't forget in previous example, v is equals to integral a dt. So when I integrate a, I will get my velocity. So let's go. So v will be equals to integral. What is my a now? My a is 3t square dt, right? So let's integrate. Again, when you integrate, you simply add what? Add 1 to the power. So let's go. That will be 3t raised to power 3, then divide it by the power, which is 3. So don't forget to add the constant plus c. This will cancel out that. So my velocity now is equals to t raised to power 3 plus c. Now in the first statement, we are told that initial velocity is 0. Initial velocity is 0. Okay, and time is also what? 0, right? So when v is 0, let's write that out. So 0 will be equals to time is 0. I mean that's 0 raised to power 3 plus c. So therefore, my c will be equals to 0. And I told, okay, we should find velocity when t is now what now? 2. So my velocity also is t raised to power 3 plus c, right? So we're looking for velocity now. That's equals to, what's my t now? My t is now 2. That will be 2 raised to power 3 plus my c is 0. That will give me 2 raised to power 3 is 8. So my answer is 8 meter per second. Are we following? Are we following? Are we following? Are we following? Okay, next question. In the absence of question, let's move on. So the next question, let's solve this. Okay, let's solve that. Let's solve this. But I believe by now we should be able to attempt this question. Okay, who can quickly attempt this for me? Can quickly attempt this for me? Drop your answer in the comment section. I'm giving us just 30 seconds. 30 seconds to solve that question. I'm still waiting for a solution. I'm waiting for someone's solution. So let's be fast. Let's be fast with this. Is the question clear now? Okay, I think I will just go on with the solution. No one is giving me an answer.